All right, so now we switched to working on chat with documents, and Beck built a backend for that. And the big lift on this was actually getting the document parsing part to work well. So we spent a fair amount of time trying out the different ways to extract data, particularly from PDFs, which it seems like a lot of people use.
Mhm.
And Beck settled on, and we want all this to be open. We don't,
Yep.
we not only want it to be local, but we also want it to be open source. So we maintain, complete freedom, ownership, and control over our system. So Beck settled on, after a lot of research, Dockling as the document extraction framework with natural language processing algorithms that go along with that. And that's kind of like the dockling setup that Beck has done is kind of like the gold standard in
Yep.
terms of parsing text from PDF documents, because it's using these natural language processing algorithms. So you're getting a lot more sort of metadata that you're not getting with other extraction services. Like it does a really good job, for example, if there's data in a table, to make sure that you maintain that
Yep.
structure, because just having the data without the table structure is obviously not as good. And that originally was a pretty intensive process that we couldn't get to run locally.
Mhm.
But after playing around with that and putting it into Docker, Beck was able to get this document processing service working locally via Docker.
Yep.
On my computer, it loads in like a minute and a half, but I have fast computers. So on slower computers, it takes like 10 or 15 minutes for this thing to load, which is not ideal.
Yep.
Before we go into what he's doing now, so the first piece is like, we need to be able to upload these documents, and we need to be able to parse the data. Then we need to chunk it, and we need to embed it into a RAG database. So Beck, this is where I don't know all the names of the models and stuff. So what are we using for the database and for the embedding model?
Okay, yeah. First point in terms of optimization for document processing. Initially, I was using Spacey Layout, which uses Dockling for document processing plus Spacey for NLP,
Mhm.
and that's why first Docker build or image was around 10 to 12 gigabytes of size, and it was very big. That's why it was taking sometimes even around 20 minutes
Yep.
on my computer. So I was doing this optimization, and then I found this that Spacey Layout uses Dockling. So I switched to Dockling because we are not using any NLP techniques in the pipeline yet. I wrote another adapter. Now it uses Dockling, and its image size is about now 3 gigabytes or 4 gigabytes, something like this. So it's very like huge optimization. And the first build of Docker image takes about 6 to 7 minutes on my computer, which is slower. On
Mhm.
your computer, it will be like less than a minute. But after first build, any other rebuilds will be very fast within 10 seconds, 15 seconds. So this is now we're using Dockling, and Dockling also uses some models. And I use the one that let me actually pull.
Just one more thing to add in while he's bringing that up, Dave, is
Yep.
these things are separated out, so you can like turn on the document processing service while you're doing your document uploads and embeddings and stuff, and then turn it off as
Yeah.
well.
Yeah. Once you've chunked all your information, it's in your vector database and like that, you don't need to run it anymore. So you can shut
Right.
it off and just go straight to the database as far as your
Which is cool, because while we're not using the spacey layout stuff right now, like I think that's very valuable. And
Mhm.
especially if you're a company that's going to be, chunking up a bunch of documents and PDFs, and like you just let this thing run all night,
Yep.
and do all the processing and everything. And you come in the morning, you turn it off, and you're faster again and all that.
Yeah, I pasted the message here in the chat. That's the model that used for Dockling, and it's preloaded within the Docker for the backend for this document processing.
Yep.
And I did that so that it will work even if you're offline. it will still work. So it wouldn't pull it from HubSpot or any other sort.
So this is DS4SD /Dockling-layout-Heron. That's an open source embedding model, or what is this?
No, this is the model that Dockling uses for I don't know, for their document processing.
Yeah,
And
it looks like it determines the layout that's in
yeah,
the document so it can determine what it needs to do next with it.
Okay,
yeah,
so is this an NLP algorithm, or we don't know, or
Uh, No, this is
it,
this is a model that's been fine tuned and trained. I can't see what it's using as a base. But anyways, what it does, it goes through your document by the looks of it, and determines, do you have text, do you have a list, do you have a table, and then it extracts that, so then it can go through the model and then put the information into a chunk. Did I get it
yep,
right back from your research as well?
yes,
Yeah. Okay.
yeah. And it's a machine learning model,
Yep.
and it's available on open source on their Hugging Face page.
Yep.
okay? So this is basically a lighter version of what Spacey Layout is doing. Is that an
Mm,
accurate to say?
Uh, no, spatial layout. Okay, so Spacey, it's NLP, it's natural language processing, and they created this spatial layout, which is document processing combined with NLP. So spatial layout also uses docling for document processing plus their NLP techniques. And that was my initial library for document processing, spatial layout. And we didn't use any NLP techniques in the pipeline when we were extracting text or
Hmm.
doing chunks or all of this. That's why I switched to dockling, because we only need text extraction, or structured text extraction from files, PDFs, and any other file format. That's why we're using dockling now.
So if we have what would we be missing? When would we ever say, hey, we want to add the Spacey layout in because what?
Uh, if you remember, you started, uh, we built the first version of BrainDrive memory with Neo4j. So it was graph database. It means we didn't extract, like when you chatted with this agent, behind the scenes, it was analyzing your conversation with AI and pulling or providing context for this AI agent, right? So it would store something from your conversation or enrich your conversation something from your stored memory. And the database we chose was graph database. It was, you remember all these nodes and links, connections between each entities.
Hmm.
If we wanted to simulate that, we could use spatial layout so that when we process these documents, we don't just store them by chunks, but we also store how each chunk is connected to each other, or how like larger documents connected to each other.
Yep.
For that thing, we can use spatial layout, but that will increase the processing because we would do this additional NLP technique, like
But this
analyzing
will make
entities.
the retrieval more accurate if we do it well, right?
Yeah, it will provide like additional context in terms of how are they related to each other.
Okay. Does that all make sense to you, Dave?
Yep. Yeah, because I
Okay.
played with Dockling already. That's why when I even suggested it, and we brought it up on conversation. It was like, so I've played with it, and I know the graphs and hierarchical indexing and such like that, and semantic searching. So far I'm good. I'm doing good.
Okay. All right. Now, my understanding is in addition to this embeddings and chunking what's the database that we're using for the embeddings? Chroma?
ChromaDB.
Yep.
Yeah. Okay. That we also have another type of search, which is just like keyword based, right?
Yep.
Is that right, Beck?
Yep.
Yep, that's BM25.
Okay. And so basically, we're saying sometimes, like, if you're, my understanding of this is from a high level, is if you need, like someone has said Apple, and you want to know whether that's Apple computer or Apple the fruit,
Yep.
that's where embeddings and these semantic
Yep.
relationships come into play. But if you want to find the word Apple in a document, then the keyword search is going to be better because it's going to return the exact document that has the words Apple in it, right? And these things may work together, right? Okay, I've identified that this Apple is the company, and they're looking for a document, their Apple financial statement, and I'm using the keyword search for that, and it's bringing me back this financial statement. Is that right, Beck?
Yeah, correct. But it will be more useful in terms of dates. So if you ask for specific dates, embedding will return you the relevant search for the date, not exact. Like if you are asking something in 2025 or June 2025, it's going to return you, it might return you similar relevant to June 2025. But keyword search would return you exactly any chunks that has this June 2025. And currently it runs this hybrid search, so it runs parallel embedding and also keyword search. And the weight currently for each of these, they are not like embeddings is not prioritized or keyword is not prioritized. It's 50-50. Then LLM decides which one to use for
And
like
this is
from
that
what of them.
library agent. I call it this library agent, right? So we
Yep.
have the embedding model, we have the keyword search model, which you said, what was the name of that again?
BM25.
BM, B as in boy,
Yep.
BM25.
B as in boy and M as Madrid,
Mike.
BM25.
Okay. All right. And then we have this library agent, right? And that's a model as well, correct?
Yep.
What model is that using?
The one that you set, if you're using in BrainDrive, the one that you set in BrainDrive settings, like plugin
Okay.
component.
That's not
So,
set by his system. That is set by the user when
okay,
they
but
set.
we could in the future recommend a model that we feel
Yep.
like is good at each size and all of that we've
Yep.
tested out and blah blah blah.
Yep.
Okay. All right, but and can you change and my understanding also, this is important, is once you've chosen an embedding model, technically you could change it, but you really don't want to because you have to re-embed everything and it's really going to mess things up, right?
Correct.
It
Because
sounds
you
like
have to reprocess all the document. If you change your embedding model, all of the documents that you put in have to be
right. And that's
reprocessed.
the point of lock-in and lack of freedom and ownership and control that I don't think a lot of people are thinking about is like
Yeah.
if I'm using a closed source embedding model that I don't have ownership and control over, but even if I own and control the rest of the thing, that is a real point of leverage for whoever owns that embedding algorithm.
Yeah, because all that wasted compute that you did to build your RAG setup, your your vector database would be just sitting there and it's locked.
Okay, so
Good
all
luck.
three of these are open source, but my understanding is, Beck, if you want to use a different search model or a different embedding model, you've built the system in a way that you can.
Yeah.
Yeah.
Okay, which is the freedom, pillar of BrainDrive. Okay, amazing. All right. And ChromaDB is also open source, and it's one of the most
Yeah.
popular open source
Yeah.
embeddings bases. And all of this can run locally, right? Even
Yep.
on a relatively slow modern computer.
If you get
Yep.
stupid, slow, old computer, hey, your mileage will vary. I'll be blunt right here. I know it for
Yeah.
a fact. Okay.
Yeah, but I mean, I think you don't need a $3,000 computer
Nope.
to run
Nope.
this,
No.
so which is cool. Now you can host different pieces of this in the cloud as well.
Yep.
So if you want to use a bigger, model with Olama, just host your Olama in the cloud and run a bigger model, or use an API to a virtual private server, or like there's many different options in terms of how you can scale the sophistication from a processing power standpoint up and down with this thing.
Yep. You could get on Google Colab, run your document processor service there, use their graphics card for free, and turn it off when you don't need it, since it's an optional piece and like that. That's how modular they really are at the end of the day.
Okay, great. All right, now so we've built this into BrainDrive. Or Beck has.
Mm-hmm.
He hasn't quite got the dark working yet, but that's fine. And okay, so how did you go about doing this piece, Beck, or unless there's something else you want to add to what we've already discussed?
One more thing, there is one optional. It's about the processing the document
Mm-hmm.
before embedding. There is one more optional LLM or processing in this pipeline, in RAG pipeline. It's called contextual extraction. And for this one, if you notice in the setting, you have three LLM, two LLMs, one for chatting and the other one is for this contextual retrieval. And the third one is for embedding. So contextual retrieval, this is, we not just extract text and then slice them up and generate embeddings. For each sliced chunk, we also generate like one or two sentences in terms of how this chunk is relevant within the overall document. So there is like a summary of how this chunk is relevant to overall document. And this is optional. We can turn this off or on, but I think this improves a lot also the retrieval, because sometimes if you just retrieve the chunk, it provides additional context. Okay, now I retrieved two or three chunks. How are they all related to overall document structure? So this is like an additional context.
And that's in addition to what would be the normal token overlap. Like, let's say if you're pulling 400 chunks and you're doing 100 on each side of that overlap, then you have the contextual of where it fits in the overall document itself.
Yeah.
Okay.
And that's a fourth model then, so there would be
No, there's three.
Two LLM models, one embedding model, one machine learning model for document processing.
Okay.
okay. So which model does the contextual processing?
It's very small model, the one that I use, but you can change it also in the setting. And I think you've switched it to the one that you have locally running.
Okay.
Yeah.
All right, so walk me through. I go into my chat with Docs. I've got the plugin downloaded. I'm going to my chat with documents page, and the first thing I do is I upload these documents, right? So I've got some BrainDrive, our vision document. I've got a guide that I wrote on how to run AI on your computer privately and freely. And I forget what this is, but it's also something about BrainDrive. So I upload these documents. Walk me through what's happening here.
Okay, in the backend, first step, it validates the file type. If file type is fine, then it extracts the text, and we use this docling for text extraction. It returns the structured representation of this file. Then we slice this extracted output from docling into the chunk size that is defined in this backend. And I think the default one is 2000. But we can change this with configuration, not in here, but in the backend itself. So there is chunk size. We slice them up into these chunks. And then for each chunk, we generate this contextual information, how this chunk is relevant. And it's just the text for this chunk. When this is done, then we index them, generate embeddings for each chunk and store them in vector store in ChromaDB. At the same time, we also index them through this BM25, and it's also stored in the local index BM25 index file.
The chunks are indexed in BM25.
Yeah.
Yep.
Okay. All right. All right, so and once that's all done, then the documents are there and the chunks are in the ChromaDB. That's what we've done. Okay.
Yes, and if this all was successful, you will get notification, green notification saying, okay, document was processed successfully. If not, you will get this error notification.
Yep. Okay, right here, processed. Okay, now, all right, I open up a new chat and I type in what is BrainDrive. I might not have everything running here. So anyway, I'll figure that out, but
Yeah.
oh, there it goes. It just needs to load up the model. Okay, so this is because it's a thinking model. Is it a thinking model? I don't think so. No. Here's
Nope, that's a response.
okay. BrainDrive is a revolutionary open source system designed to put you back in control. It's built around that. Okay, so great. What's happening? What just happened? So I know one thing that happened is the model had to load, which is why it was a little
Yep.
slow, right? But
Yep. And
let's just see right here now if I do, you know, can I build on top of BrainDrive? Okay, so it's a lot faster the second
Yeah.
time. And this is all correct too. Okay, so what's happened? So the model loads. I type in what is BrainDrive, model loads, and then what?
so the one that you're saying model loads, it's we have to put or cold start the embedding model because the one that you use is from Google Cloud, hosted on Google Cloud, and initial uh, prompt or input took longer, processing took longer, but second time it was fine. But what's happening there when you type the message, hit enter or submit, it first searches for relevant content from this backend, pulls the relevant content, and whatever is returned then is submitted to BrainDrive through BrainDrive API, BrainDrive Core API to generate the response. That's how this is how it works currently. It's not using agent from the chat with documents plugin. It's using the what you call this, generating response from BrainDrive Core API.
Which is how it's supposed to work, right?
It should work like this. Yep. So it pulls only relevant content from this what you call this plugin service or
Hmm.
chat with documents backend, pulls relevant content, and then this content is then submitted to BrainDrive Core API to generate response together with your message.
And the back end that you're talking about is running in Docker.
Yeah.
So that is the two things that are running here are the document processing and the back end for, which is what this plugin is communicating with.
Yep.
Yep.
Okay. So I type in what is BrainDrive, the model comes up, and it's going to the back end where the database is, the ChromaDB database is, and it's searching through that and it's pulling back the relevant chunks and creating the response.
Yes. And if you share your screen again and open this console, developer console from this browser, switch to, okay, network, and fine. Can you switch to this fetch/XHR tab? Yep. And can you type something again? So you will see here what's happening here.
It looks like when I do that, okay, here we go. Gotta get the responsiveness. Okay.
Yep.
Is BrainDrive open source?
There we go.
Okay. You see, there is first one, it's search request.
Okay.
On this, and this is what you get as a response here. You get a lot of chunks for your query. These are all the chunks that you get from your Docker chat with your documents Docker backend.
Right. This is where it talks about it being an open source project.
Yeah. So you
Okay.
can see these are the chunks, the relevant chunks for your query. This is
Cool.
not the response yet, but this is just context or relevant chunks to
So
your
it's
query.
pulling all the chunks and it's synthesis. And where does the search, where's like the keyword search come in here, if at all?
Now, switch to payload tab. your query was, is BrainDrive open source? So it returned chunks based on this query, the one that's you submitted.
So that's where the key BM25 comes in.
It's no. Okay, I didn't understand your question. Keyword search is happening in the backend. You don't see it in here. You see all of them. It's mixed up. Embeddings chunks and keyword chunks are all in one. You don't see them.
So it's
But
saying, okay, what is BrainDrive open source? It's going to the back end and it's doing both. It's looking semantically for this, and it's also searching based on the search term, and
yeah,
it's pulling back context, and then it's synthesizing all of that into the answer that I got in the chat.
yes. So the next one is, you see there is chat request after search. Switch to this chat request on the left, yeah. So this is where you submit this request to BrainDrive core, and it should be somewhere here. Wait, page context. Okay, yes, I attached it to this page context. So
Okay.
this the context that you get from search, it's submitted to this request. Then BrainDrive core, I don't know, backend generates the response based on your question and retrieved relevant content from the search.
Okay, cool. All right. So that's basically how all this works.
Yep.
Anything else that we should point out about it, Beck or Dave?
Let me add something just so for your recording. I know you transcribed. What he's doing is similar, is you're normally called a hybrid because he's using both the chunks and the BM25 or keyword searching. And it's not a separate thing anymore when you use hybrid searching. You're just going in the middle. It does both, puts them both together. And from that, it figures out what you need as a response.
And that seems like a great way. Like that
Yeah.
makes a lot of common sense, which I always like.
Yep. Everybody's moving to it. He's so it's it's business as normal.
Okay. All right. Anything else you want to add, Beck, that we haven't talked about?
No, not
Okay.
yet.
So we started this process a few months ago.
Yep.
We know that in AI time, that's like 3 years. So if we were starting this today, would we build it in the exact same way, or would you have built it in the exact same way, Beck, or would you have considered doing it differently?
If we're talking about making it local first, I will build the same way.
Okay, and why did you have that caveat?
Because if you remember, I like when we switched to from BrainDrive memory to locally first, okay, making it work with local models. I focused on making this, okay, if local models are not as intelligent as, I don't know, proprietary models like ChatGPT or Claude, we need to make this retrieval process as much sophisticated as possible, because the key is here then not the LLM, but the retrieval part. So we need to make this as advanced, sophisticated as possible. And I used a lot of like best techniques or approaches that possible to make this as accurate or as sophisticated as possible. Up to this state, I think it's still the same. There is nothing else in terms of making it more sophisticated than that.
Can you talk about the things that you did to make it more sophisticated so it would run locally?
First selection is about this getting structured output from your files. That's the key. That's I know it's a small difference, but if you get this as you talk, if you extract just the text without any structure, it's fine. But if you also provide this additional structure context, it improves it a little bit.
Okay, so let me
Then
just say that back to you as the first thing, because this would be like, hey, if I've got someone who's really experienced, i.e., GPT-5,
Mhm.
I don't need to provide them as much context. I can just say, hey, go get me this, and they'll figure it out because they're
Yeah.
experienced. But if I have someone who's newer and not as experienced or as intelligent, I need to give them a lot more context. So that's what you're saying when you did the processing. you added a lot more context than you may otherwise have done, so smaller models can pull the data accurately. Is that right?
Yes, that's the like small thing. First, you get structured output from your text, and then there is different strategies in terms of how you can slice your chunks. There is again, you can slice them by I don't know, meaningful chunks, or but the one that we did, it's using the default chunks with overlap. And why I did with like straightforward chunks based on characters count, 2000 characters with overlap, because anyway we generate this contextual information for each chunk, and that's why I did that. So this alone, adding this contextual retrieval to each chunk or contextual information for each chunk, this also improve a lot in terms of how accurate will be the retrieval part. And the third one is adding, not just embedding, you're running basically this hybrid search or keyword search.
Okay. And basically all the things that you just mentioned are all done for that same reason that I talked about, which is we want this to be able to work with less intelligent models that are because we want to be able to run smaller models.
Yes, because the key here, okay, you ask question comes from the user. Then you need to provide context for this. Context comes from this retrieval part, not from LLM. And then if you have like very dumb model or less intelligent model, this model only needs, okay, here is the question, here is the context, please answer it correctly. That's the reason. And so of course we need to focus on, okay, to get the most relevant context as possible to this question. That's what we focused on. Next step here we can do is improving the search intent or search query, because right now it uses the your prompt or your input directly to search through for the relevant context. And this is the next optimization that we can do, like classifying or identifying the intent of your query before we do the actual search.
This
That's
is making this person that's actually using the system smarter, right? It's like, what do they actually mean when they say is BrainDrive open source, and perhaps modifying that search term a little bit to be, get better conveying the actual intent of what they're asking to the model.
Yeah, which is still in like it's still we want to improve the retrieval part, because we optimize the query to get the most accurate response. So there is still optimization there in terms of optimizing the query itself,
Okay.
the search query.
It also sounds to me like we need to recommend models at different sizes, that are going to give you the best results.
Yep.
Okay.
Let me also, before you get started, state that when you're doing like local versus frontier model type stuff, it is, if you go to frontier first, which is Claude, OpenAI stuff and like that, it is much harder to go backwards and get it to work the same versus the other way around. Like he said, I would have started at local, because if you can get your stuff working on local, this is easy. This
Right.
will just turn what you throw change the model, and it'll just all work. This is the challenge. Is
Right.
always
So
right
we
here.
start with the smallest models, and you can always go up and
Yep.
make it better. But if you start with the big models, it's really hard to go down.
Yep.
Okay. But Beck, you said if I was going to build a local system, I would have done everything exactly the same. Nothing would have changed over the last few months. But if you were going to build a cloud-based system, what, if anything, would you do differently if you were starting today versus several months ago?
Okay, first, of course, now once I build the system local first, I would do the same way for proprietary model. But if you remember when we started with BrainDrive memory, with the one with Neo4j, I used more advanced databases or storing this not just as an embeddings, but also the entities and relationships, all this stuff. This to make this work with locally first model to generate not just embeddings or extract the chunks or I don't know, store these documents as embeddings or index them force this lexical search. If we switch to graph database, of course, it improves a little bit because it also provides additional context now in terms of not just, okay, about this chunk and the document, but also a few different other documents. How are they related, or the relationship between each chunks? For this one, there is a minimum model that you, like if you use Gemma 3 billion, 7 billion, it wouldn't work with graph database.
Yeah.
If you remember, we tested with 72 billion parameters, it was working well, but not as much as with, I think ChatGPT 4 at that time was one of the
Yeah, I know you guys jumped to a higher model and still wasn't satisfied with what that was doing compared to the Frontier.
Yeah. So with proprietary model, I would do the same way, except I would switch to graph database, not ChromaDB.
Okay, and the reason why we're not doing that locally is because that's just too much overhead on the computer to do the knowledge graph part of it and creating those
It
relations.
would fail a lot, yeah. Depending on the model.
Yeah.
Okay. All right. Okay. So I hear often like, oh, RAG is dead. You know what I mean? And we're gonna do agentic blah 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 now. Is RAG dead? Why is RAG not dead? What are your thoughts on that?
People are
I,
smoking crack. That's my honest response. Well, no, because the people that are going rag is dead are looking at things that don't exist yet, and they're trying to almost beat the curve. Like they're almost going, okay, the context is going to be at 250K soon. Well, it's been sitting at the most, sitting at a local owned system about 100K, and then even then you have to have serious hardware to hit it. Most people are down to the 12K, 16K ranges and stuff like that. For that, you need RAG because you have to be able to get just what you want.
Well,
Put
and
that in.
also like even on the Claudes and the Chat GPTs of the world, like once I get long into a chat and I'm nowhere near the million
Yep.
token window, whatever it's supposed to be, and it's like you can see the degrading of the.
Because they're not efficiently using memory as well. They're relying on the fact that they know they could toss the kitchen sink at their model and it'll run every time. But you get 10 questions into it, and they have charts that show as the context window starts to fill up, like at 64K, it goes from 100% down to like 90% efficiency. And
Yeah.
then when they hit 125K, suddenly they start hit 70K and drops it really dramatically
All
after
right, and
that.
also the other thing that I've found is it's one thing. This is what I'm talking about in terms of the chat experience degrading is if I'm talking about the same thing, and if I'm jumping in and talking about my health and then work stuff and finance stuff, like it's just not there.
Yeah. No,
Okay,
but I RAG has a long ways to go as in life. I do not see it even coming close. If it moves to anything, it'll be a division of short term, long term, and that'll probably be the next step, not death.
okay. Anything you want to add on that, Beck?
no, I still think RAG is not dead, of course. And yeah, people just want more context window. And I think it depends also how you build this RAG system. Not so many applications use this, the latest or the best techniques possible.
Got it. Okay.